Welcome to this lecture on operating system. In today's lecture, we will learn about CPU scheduling in detail. The courtesy or the reference taken for this presentation is from Silver Chats. Basic concepts of CPU scheduling. So CPU scheduling, we need to utilize the CPU to the fullest potential. So that is a maximum CPU utilization obtained with multi-programming. So already we learned what is multi-programming. More than one processors are available in the main memory, so that the processor CPU can switch from one process to the other process which is ready available in the memory, so that it can switch between the processes. Now here there are two cycles that can be possible, either CPU IO burst cycle, we call it as process execution, consists of a cycle of CPU execution and IO. Okay, so it is a computation cycle or it is a IO cycle. So the CPU burst distribution is of main concern. So because we need to utilize the CPU at the fullest potential. So there is a sequence of CPU burst and IO burst that can take place in normal load store instruction execution flow. Now what is the CPU scheduler is? The CPU scheduler selects among the processes in ready queue and allocates a CPU port to one of them. So it is a scheduler responsibility to choose one among the several available processes so that it can get the attention of CPU. Now the queue may be ordered in various ways. The CPU scheduling decisions may take place when a process, there are four different situations in which the scheduling decision can take place. So the first situation is when the switches from running to waiting state. So when a process switches from running to waiting state, a new process, another process which is in the ready queue should be getting the attention of CPU. So that is the first situation. The second situation is process switches from running to ready states. So running to waiting state also we need to choose a new process. The scheduler should choose a new process. From running to ready state also it should choose a new process. The third situation is when a process switches from waiting to ready. When a process goes from waiting state to the ready state. And the fourth situation is that when a particular process terminates. So for situations 1 and 4 there is no choice in terms of schedulings. A new process must be selected for execution. Okay, for situation 2 and 3, okay, so there is another way of choices. There are several choices. So when scheduling decisions are to be made, there are two different categories, preemptive scheduling and non-preemptive scheduling. So what is this preemptive scheduling? So preemptive scheduling is it can taken away by force. So when a particular process is given the attention of CPU, and if a higher priority process comes or any other interrupt comes, the corresponding executing process can be temporarily stopped and the context switch, the CPU context switches to the another process. This kind of taking away by force, we call it as preemptive scheduling. Okay, so when scheduling takes place under circumstances of the situation 1 and 4 described in the previous slide, the scheduling scheme we call it as a non-preemptive. Non-preemptive means it cannot be taken away by force. The corresponding process, once getting the attention of the CPU, it will be completed to its fullest. Okay, it cannot be interrupted in between. So under the non-preemptive scheduling, once the CPU has been allocated to a process, the process keeps the CPU until it releases it either by terminating or switching to the waiting state. Okay. Preemptive scheduling can result in race condition. Okay, so when the data is shared among several processes, okay, considering the case of two processes that shares the data, while one process is updating data, it is preempted so that the second process can run. The second process then tries to read the data, which are inconsistent state. Okay. So dispatcher. The dispatcher module gives control of the CPU to the process selected by the CPU scheduler that involves switching context, switching to the user mode, or jumping to the proper location in the user program to restart that program. So here one term we call it as a dispatch latency. It is a time it takes for the dispatcher to stop one process and start another running. So that is the time in between the stopping of one process and the starting of another process. We call it as dispatch latency. Now the CPU scheduler has a basic criteria with which the algorithm should be designed. So there are 4 typical scheduling criteria. First one is CPU utilization. Keep the CPU as busy as possible always. Throughput, number of processes that is completed their execution per unit time. Turnaround time, amount of time to execute a particular process, that is from the submission of the process till its completion. Waiting time, amount of time a process has been waiting in the ready queue. Response time, amount of time it takes from when a process request was submitted until it is getting the first response. So there is 5 different criteria. Here, which are all the criteria we need to maximize and which are all the criteria to be minimized. CPU utilization and throughput should be maximized. Turnaround time, waiting time, response time should be minimized. So CPU maximum, CPU utilization, maximum throughput, and turnaround time, waiting time and response time to be minimized. Now we will learn about the different scheduling algorithms, out of which the first one we call it as a first come first serve FCFS scheduling algorithm. So this is a typical example with which we can understand how the scheduling, FCFS scheduling is implemented. So there will be a static information available given to us is a number of processes and what is the corresponding CPU burst time each process is required. So in this example, there are 3 processes P1, P2, P3 and the corresponding burst time for P1 is 24 millisecond, P2 is 3 millisecond and P3 is 3 milliseconds. Now for understanding the FCF scheduling algorithm and other several algorithms, we are in a position to prepare a Gantt chart. So, and Gantt chart is nothing but a rectangular box that specifies the start time of a particular process which is getting the attention of CPU and at what time it ends, with which we can calculate the several times. Okay, so for example in FCFS means whichever process has arrived to the ready queue first, that will be serviced first or that will be getting the attention of CPU first. So we will consider the order in which the process is mentioned in the table. So P1, P2, P3, because this explicitly there is no arrival time given. Okay, so we will consider if the arrival time is not specified separately, we will consider that all processes P1, P2, P3 are available at 0 milliseconds. Okay. Now because we need to service in order, first P1 will be serviced. So because P1 has requires 24 millisecond of burst time, it will get the attention of CPU for 24 milliseconds. And after 24 milliseconds, P2 will get the attention of CPU. So it will execute for 3 milliseconds. So 24 plus 3 is 27. At 27 millisecond, P3 will be getting the attention of CPU. So it will execute for 3 milliseconds. So 27 plus 3, 30. Now when you're preparing the Gantt chart, okay, so the total burst time 24 plus 3 plus 3, so totally 30. So here also we need to end with 30. So you can cross check your answer while preparing the Gantt chart whether the corresponding total burst time it is available in the Gantt chart also when all the processes are scheduled correctly. Now the question is how to calculate the waiting time. The waiting time of process P1 is 0 millisecond because all the processes arrived at 0 millisecond and immediately 0th millisecond itself P1 is getting the attention of CPU. So P1 waiting time is 0. What about the waiting time of P2? P2 waits until P1 is completed, that is 24 milliseconds. So P2 gets the attention of CPU at 24 milliseconds. So P2's waiting time is 24. What about P3? P3 is waiting until P2 completion. So it is getting the attention of CPU as 27 milliseconds. So P3's waiting time is 27. So how to calculate the average waiting time? Add 0 plus 24 plus 27 and totally divided by number of processes in the system, which is equal to 17 milliseconds. Now there is another parameter to calculate. Actually this is not available here in this slide. So it is called as turnaround time. So how to calculate the turnaround time? So turnaround time is the time with which the corresponding job is submitted and at what time it has been completed. for example, if you take the turnaround time of P1, so P1, it is completed at 24 millisecond. It is submitted to the ready queue on 0th millisecond. So 24 minus 0, 24. So P1 turnaround time is 24 millisecond. What about the turnaround time of P2? P2 is completed at 27, right? So P2 turnaround time will be 27 minus what time it has been submitted in the system. It is also arrived at system at 0th millisecond. So it is 27. And what about the turnaround time of P3? P3 is 30 millisecond completed. It is arrived at the system at 0 millisecond. So P3 is equal to 30. So add all these things, 24 plus 27 plus 30 you will get, and divided by 3 you will get the turnaround, average turnaround time.